So guys, in today's video, we will be seeing certain important reactions of your carbonyl compounds. And whatever the reactions we are going to see, it is because of your alpha hydrogen atom. So our next concept we are going to see, which is called as reactions due to alpha hydrogen. Reactions due to alpha hydrogen. Very much important concept, because under this concept we are going to study majorly three important named reactions. I repeat, three important named reactions. So before going to the named reaction, first of all let us have the knowledge what is this alpha hydrogen atom is and why does it is playing such a vital role in our reactions. So in order to understand that one, I have to make sure one thing. What is that? Again and again I am repeating you. What is that? Always a reactant will try to attain a most stable state. Alva? If you're doing a reaction, it is giving you the product. We will be checking out whether that product is stable by seeing its resonance structures, by seeing its steric hindrance, and that matters a lot. And ultimately we are achieving a point where it is saying that okay, your product is stable because it is resonance stabilized, it is having less steric hindrance. Alva? When the product niಮಗೆ ಸಿಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅದೇನು, it will be in the ultimate stable state. Okay, that will be the major product. Here also the same concept arises. How is that so? Of course, when I am writing a carbonyl compound, for example, C double bond O. Yes, so beside it there will be another carbon which may have a hydrogen. Mark my words, which may have a hydrogen. So this is called as what? Alpha hydrogen atom. Why? The carbon atom which is adjacent to your functional group, that will be called as what? Alpha carbon. So that carbon mele yava hydrogen irutte, that will be called as what? Alpha hydrogen atom. When such a compound is treated with a base, yes, of course this base will try to abstract a proton. It's a tendency of a base. But do remember guys, it can only abstract a proton in an easy way. Base ಹಾಕುತ್ತ ಕೂಡಲೇ ಪ್ರೋಟಾನ್ ಬರೋ ಸಾಧ್ಯತೆಗಳು ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಆ ಕಂಪೌಂಡ್ ಆ ಹೈಡ್ರೋಜನ್ ಬಿಟ್ಕೊಡೋ ಆಸಕ್ತಿ ಉಂಟು. That is what I am saying is, if you are putting a base and a hydrogen is being abstracted that much easily, means what does it mean? Whatever the carbonyl compound or whatever the compound you have chosen, it is also reluctant. Okay, it is also reluctant to give that proton. Then only the reaction is going in an easier way. ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಹಾಕಿದ್ವಿ, ಅದು ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಉಂಟು ಅರ್ಥ ಏನು, the other reactant is also trying to get involved in the easiest way without any drastic condition. Of course I am saying that here I am using a base, it is abstracting a proton. It is an easy task, but we have to think in another way. Why does this carbonyl compound is also reluctant? That is why it is also being very enthusiastic to give this proton. The answer lies over here, because the carbonyl group, what you are seeing over here, it is having an electron withdrawing effect. Alva? Electron withdrawing effect. That means what? Due to the electronegativity difference between your carbon and oxygen, this bond will try to be withdrawn by your oxygen. Ultimately your carbon will be having a positive charge. In order to balance this valency, what it will try to do, it will try to take this electrons towards itself. So ಅವಾಗ ಏನಾಗುತ್ತೆ, H ಪ್ಲಸ್ ಹೊರಗೆ ಬರೋ ಸಾಧ್ಯತೆಗಳು ಜಾಸ್ತಿ ಉಂಟು. H ಪ್ಲಸ್ ಹೊರಗೆ ಬಂದ್ರೆ ತಾನೇ ಈ ಬಾಂಡ್ ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಅಲ್ವಾ. ಸೊ ಆಲ್ವೇಸ್ ಇಟ್ ಇಸ್ ಇನ್ ದಿ ಮೋಡ್, ಅಥವಾ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಕಾರ್ಬನ್ ಕಂಪೌಂಡ್ ಯಾರಾದ್ರೂ ಸಿಗ್ತಾರಾ ಈ ಹೈಡ್ರೋಜನ್ ನ ಕೊಡಕ್ಕೆ ಅನ್ನೋದನ್ನ ಕಾಯ್ತಾನೆ ಇರುತ್ತೆ. So once if your base has been employed in your reaction, of course it is also very enthusiastic to give this proton and become resonance stabilized. So this proton will be easily given. Are you able to understand? So that is the reason we are going to study these, whatever the remaining reactions are there, in the presence of base. In the presence of base. As I mentioned, so once what is happening is the taguntaun, that is this base is abstracting this proton. So once it abstracts, what happens, let us see. So now This proton has been gone, so here you are having a negative sign. Of course, this oxygen now, it will take these electrons, yes, and this negative part will be forming a bond over here. So we are getting a resonance stabilization of our carbonyl group. Alva? So here such a resonance effect arises. So though it has given a proton, it will not remain unstable, whereas it will attain a stability through the resonance structures. So that is the reason the alpha hydrogens are very much acidic. And due to this acidic nature of the alpha hydrogen atoms, we are going to study 3 important reactions which are called as, one by one I'm going to say its name, very much important. The first part we are going to study, which is called as aldol condensation. Aldol condensation. First important reaction. The second most important thing, which is called as cross aldol condensation. Cross aldol condensation. Remember, these 2 reactions are involving your aldehydes or ketones which are having the alpha hydrogen atoms. If these 2 reactions has to take place, mean what you should remember, that your carbonyl compound, that is your aldehyde or ketone, should have the alpha hydrogen atoms. And of course there is one more reaction which is called as Cannizzaro's reaction. What is it called as? Cannizzaro reaction. So basically this is a reaction, okay, which is not involving your alpha hydrogen atoms. Not involving your alpha hydrogen atoms. And do remember one of the common thing, all these 3 reactions are taking place in the presence of base. Taking place in the presence of base. Iveldukke ನಾವು dilute NaOH na use ಮಾಡಿದ್ರೆ, in both the cases we are using dilute NaOH or a KOH, whereas in a Cannizzaro's we are involving a strong solution of your NaOH and KOH. Okay, why it is so? What will be happening? We'll be seeing one by one in our video. Okay, so first of all, let us now deal with the first important reaction, which is called as aldol condensation. Aldol condensation. So now first, understanding the overall concept of aldol condensation, first let us understand what do you mean by condensation reaction. Condensation reaction in chemistry. Condensation reaction in chemistry. Remember, I'm not just talking about condensation. Of course, we have seen what do you mean by condensation process. But now we are going to talk about a reaction which is called as what? Condensation. So remember, condensation reaction means it's a reaction in which two molecules will combine. Two molecules will combine to give a larger molecule. Mark my words, to give a larger molecule. But along with that, the important thing what you have to remember is producing. So along with a larger molecule, it will also produce a small molecule. A small molecule, like, for example, I am giving like water as a byproduct. Like water as a byproduct. So such reactions are called as what? Your condensation reaction. Mark this definition because we are going to see these type of reaction in both of this. There is your aldol condensation and a cross aldol condensation. So ಏನು condensation reaction andre? So it's a reaction in which you will be having like this small caps allira 2 molecules na consider ಮಾಡೋಣ. ಇದು ಒಂದು molecule, ಇದು ಒಂದು molecule. So they are what? Smaller molecules. So what they will do? They will now try to combine with each other. So when they are combining, what is happening? You're getting a larger molecule. You're getting a larger molecule. Along with this larger molecule, we will be having a small products, which will be a byproduct, and those byproduct can be water. Mark my words, can be. Okay, I don't want to confuse you by giving some other byproducts. Generally, we'll say that the important byproduct in a condensation reaction, generally, it will be water. Are you able to understand? So such reactions in which two simple molecules are combining to give a larger molecule along with a simple byproducts, that may be your water. So such type of reactions will be called as what? Condensation reaction. Okay. So now let us talk about our aldol condensation. Okay. Mark my words, aldol. You will only have to answer why this condensation reaction is called as aldol. Okay. So beginning with, remember, so these type of condensation reaction, I have already explained that it should have an alpha hydrogen atom. Okay. So let us have a definition of it. Remember, aldehydes and ketones, having alpha hydrogen atoms undergo a reaction, yes, in the presence of dilute alkali. Mark my words, I am using over here as a dilute alkali as a catalyst to form first of all beta hydroxyaldehydes. So that product is generally called as what? Aldol. Because hydroxy unto, which means what? Alcohol. Aldehyde unto, which means ald. So overall aldol. Of course, it can also give aldehydes tagundaga nimge aldol barutte. Adelladu ನೀವು ketones ತಗೊಂಡ್ರೆ ಏನು ಬರುತ್ತೆ? You will be getting as what? Beta hydroxy ketones, which is called as ketol, what? Ketol, respectively. I should add the word as what? Respectively. Okay, respectively, aldehydes which contains an alpha hydrogen atom undergoes a reaction in the presence of dilute alkali as a catalyst. You will be getting as what? Aldol products. If you take a ketones treating with a dilute alkali, you will be getting a ketol product. So I should add my word respectively. Okay. So ಈ beta hydroxy aldehyde ಆಗಿರಬಹುದು ಅಥವಾ beta hydroxy ketones ಆಗಿರಬಹುದು, ಇದನ್ನ ನಾವು on further heating they lose the water molecule. Okay, they lose the water molecule to give alpha beta unsaturated carbonyl compound. So this product is called as what? Aldol product, and this reaction is called as aldol condensation. This reaction is called as aldol condensation. Tumba dodu kuntala. It looks like it is very heavy definition. Don't worry about it. Don't by heart it. Within a fraction of time, I will make you sure that you will only say your definition by seeing the reaction. But important hint what we are getting to know is, in order to carry out my aldol condensation, I am requiring an aldehyde or a ketone which will be having an alpha hydrogen atom. That much thing should be there in your mind. So let us start our reaction. So in order to aldol condensation, can I take my ethanol as a product, or sorry, ethanol as a reactant? I repeat my question. Aldol condensation reaction na madakke nanu acetaldehyde or ethanol na nanu reactant hange tagoboda. So let us write it. CH3CHO alva. So this is my alpha carbon atom. ಸೊ ದಿಸ್ ಆಲ್ಫಾ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಇಟ್ಸ್ ಹೈಡ್ರೋಜನ್ಸ್ ಅಲ್ವಾ. ಸೊ ಈಗ ನಾನು ಇಥೆನಾಲ್ ನ ಆಲ್ಡಾಲ್ ಕಂಡೆನ್ಸೇಷನ್ ಮಾಡಕ್ಕೆ ಆಗುತ್ತೆ. ಯಾಕೆ? ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಅನ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಬಟ್ 1 ಮೋಲ್ ಇಂದ ಆಗಲ್ಲ, ಸ್ವಲ್ಪ ನಾವು ಎಕ್ಸಸ್ ಅಮೌಂಟ್ ತಗೋಬೇಕು. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದು 1 ಮೋಲು ಇದೇ ರೀತಿ ಇನ್ನೊಂದು ಮೋಲ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಮಾರ್ಕ್ ಮೈ ವರ್ಡ್ಸ್, ಸಿ ದಿ ವೇ ಐ ಆಮ್ ರೈಟಿಂಗ್ ಇಟ್. ಯಾಕೆ ನಾವು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ತಗೋಬೇಕು ಅಂದ್ರೆ ನಮ್ಗೆ ಈಗ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ನಾವು 1 mole of an aldehyde is reacting with the same another mole of your aldehyde. ಯಾವ ತರ? By utilizing its alpha hydrogen atom which is highly acidic. So this one, when it is treated with dilute NaOH, mark my words, dilute NaOH. Why dilute? Because the compound itself is ready to give this proton. Because if it gives a proton, it will become a resonance stabilized as we have dealt over here. So ನಮ್ಗೀಗೇನು ಸ್ವಲ್ಪ ಕಂಡೀಷನ್ ಕೊಡ್ಬೇಕಷ್ಟೇ. ಇದು ಬಿಟ್ಕೊಡಕ್ ಇಷ್ಟಪಡ್ತಾ ಅದಕ್ಕೆ ಏನು ಸ್ವಲ್ಪ ಫೋರ್ಸ್ ಕೊಡ್ಬೇಕು ಬಿಡಕೊಡಕ್ಕೆ. ಸೊ ಆ ಸ್ವಲ್ಪ ಫೋರ್ಸ್ ನ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಯೂಸಿಂಗ್ ಅ ಸ್ಟ್ರಾಂಗ್, ಐ ಆಮ್ ಯೂಸಿಂಗ್ ಡೈಲ್ಯೂಟ್. ರಿಮೆಂಬರ್ ದ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ. We never use the chemicals as per our wish. We always try to use the chemicals as mild as possible. And the greatest example is over here. Instead of using a strong, we are using dilute because a small force is required so that we can extract this proton out and we can carry out the reaction. Okay. So of course, ಈಗೇನಾಗುತ್ತೆ ನೋಡಿ, now this hydrogen will be attacked by using the lone pair of electrons on the oxygen. Yes. ಅವಾಗ ಏನಾಗುತ್ತೆ, CH2 ಬಂದು ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ನಾವು ಬರೀತಿರೋದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಗಮನ ಕೊಡಿ. ಸೊ CH3COH. ಎಸ್, ಇಲ್ಲೇನ್ ಬರುತ್ತೆ ಈಗ? ಲೆಟ್ ಮಿ ರೈಟ್ ಮೈ CH2 is in this way. CH2CHO. ನಥಿಂಗ್ ಡನ್, ಐ ಹ್ಯಾವ್ ಡನ್. ಈ H ನ ಇಲ್ಲಿಗೆ ಹಾಕಿದೀನಿ. ಅದೇನ್ ಮಾಡಿರುತ್ತೆ, ತಗೊಂಡ್ ಕಡೆಗೆ ಎಳ್ಕೊಂಡಿರುತ್ತೆ. ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬಂದಿರುತ್ತೆ, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಇರುತ್ತಲ್ಲ. ಈ ನೆಗೆಟಿವ್ ಎಲ್ಲೋಯ್ತಪ್ಪ, ಈ ನೆಗೆಟಿವ್ ಈಗ ಏನಾಯ್ತು, ನಮ್ಮ ಈ ಕಾರ್ಬನಿಗೆ ಬಂದು ಅಟ್ಯಾಚ್ ಆಯ್ತು. ಎಸ್ ಆರ್ ನೋ? ಸೊ ಈಗ ಇದನ್ನ ಏನಾಗಿದೆ, ಇದನ್ನ ಫಸ್ಟ್ ಏನ್ ಹೇಳ್ದೆ, ಆಲ್ಡಿಹೈಡ್ಸ್ ನೋಡ್ತಿದ್ದೀನಲ್ಲ. ಸೊ ಆಲ್ಡಿಹೈಡ್ಸ್ ತಗೊಂಡ, ಆಲ್ಡಿಹೈಡ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಅನ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಓಕೆ ಸರ್, aldehydes which is having an alpha hydrogen atom, alva, alpha hydrogen atom, undergo a reaction. Okay, it has undergone a reaction. Yavaga? In the presence of dilute alkali. Okay, I have used my dilute NaOH. So this is acting as what? As a catalyst. First chain form ಆಗ್ತಾ ಉಂಟು beta hydroxy aldehyde. Why this fellow said like this? ನೋಡಿ ಈಗ. So ಈಗ ಏನಾಗಿದೆ, this is my functional group ಅಲ್ವಾ. ಸೊ ಈಗ ಬೀಟಾ ಹೈಡ್ರಾಕ್ಸಿ ಆಲ್ಡಿಹೈಡ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಯಾವ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಉಂಟು? ಸೊ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಅಲ್ವಾ, ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ ಉಂಟಾ? ಓಕೆ, ಸೊ ಇದೇನಾಯ್ತು ಈಗ ಬೀಟಾ ಹೈಡ್ರಾಕ್ಸಿ ಆಲ್ಡಿಹೈಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಆಲ್ಫಾ, ದಿಸ್ ಇಸ್ ಮೈ ಬೀಟಾ. ಸೊ ಬೀಟಾ ಕಾರ್ಬನ್ ಮೇಲೆ ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ ಉಂಟು. ಸೊ ಇದು ಜನರಲ್ ಆಗಿ ನಾವೇನ್ ಕರಿಬಹುದು, ಬೀಟಾ ಹೈಡ್ರಾಕ್ಸಿ ಆಲ್ಡಿಹೈಡ್. ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? So nothing you have to by heart. Everything is there in your reaction itself. So first I have got my beta hydroxy aldehyde. Further what they say, on heating this water molecule is kicked off. ಯಾವ ತರ, ಇಲ್ಲಿಂದ ಈಗ OH ಹೋಗ್ತಾ ಉಂಟು. ಈಗ H ಯಾವ್ದಾರ ಒಂದು ಬಿಟ್ಕೊಡ್ಬೇಕಲ್ಲ. ಸೊ ಈ H ಬಿಟ್ಕೊಡುತ್ತೆ, ಹೆಚ್ಚು ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಈಗ ಇಲ್ಲೇನಾಯ್ತು, ಒಂದು ವೇಲೆನ್ಸಿ ಕಮ್ಮಿ ಆಯ್ತು. ಸೊ ಈ ಬಾಂಡು ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಸೊ ದ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಈಗ ಏನ್ ಬರುತ್ತೆ, CH3 ಉಂಟು, EC ಉಂಟು, OH has gone out by taking this bond along with it. ಸೊ EC ಹತ್ರ ಪಾಸಿಟಿವ್ ಬಂದಿತ್ತು, ಅವಾಗ ಏನ್ ಮಾಡ್ತು, H ಪ್ಲಸ್ ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಈ ಒಂದು ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಳುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ಇಲ್ಲಿ CH2 1 2 3, one H is missing ಅಲ್ಲ. This H I should have written. ಈ H ಬರ್ದಿರ್ಲಿಲ್ಲ, that one I have written. So CH double bond. Yes, this H has gone out, but this H is there. CH CHO. Now let us talk about its another product. On further heating, they lose the water molecule. Okay, water molecule they have lost to form what? alpha beta unsaturated carbonyl compound. Why this fellow is saying like this? Now this is my functional group. So now this is my alpha, this is my beta. ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ಏನುಂಟು? ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಉಂಟು. ಜನರಲ್ ನೇಮ್ ಕೊಡ್ತಿದ್ದಾರೆ ಅಷ್ಟೇ. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಗಿವ್ ದಿ ಐಯುಪ್ಯಾಕ್ ನೇಮ್, ಬಟ್ ವಿ ನೀಡ್ ಟು ಗಿವ್ ಫಸ್ಟ್ ಜನರಲ್ ನೇಮ್ಸ್ ವಾಟ್ ಇಟ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್. ಸೊ ನಾವು ದಿಸ್ ಏನಾಗಿದೆ, ಈ ಡಬಲ್ ಬಾಂಡ್ ಯಾವ್ದು ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ಸಿಚುವೇಟ್ ಆಗಿದೆ? ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್, ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್. ಸೊ ಇದು ನಾವೇನ್ ಹೇಳ್ಬೋದು ಈಗ? ಆಲ್ಫಾ ಬೀಟಾ unsaturated alva. This is unsaturated. What type of a compound it is? Carbonyl compound. ಈಗ ನಾವೇ ಡಿಫೈನ್ ಮಾಡಬಹುದಲ್ವಾ, ಏನು ಹೊಸದಾಗಿಲ್ಲ. So whenever an aldehyde or a ketone is treated with a dilute alkali as a catalyst, first it will give you an beta hydroxy aldehyde. Yes, which itself on heating further loses the water molecule, minus H2 anta barana, loses the water molecule to form alpha beta unsaturated carbonyl compound. Okay, why I'm saying as a carbonyl? If it was a ketone, let me see what you will be getting. For that reason I'm giving a general name for them. Is that clear guys? Very much important. ಯಾವ ತರ ಬರ್ದೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ನಾನು ಯಾವ ಆಲ್ಡಿಹೈಡ್ ನ ತಗೊಂಡಿದ್ದೆ ಅದನ್ನ ಅದೇ ರೀತಿ ಬರ್ದಿದ್ದೀನಿ. ಇನ್ನೊಂದು ಯಾವ ತರ ಬರ್ದೆ ಅಂದ್ರೆ ಒಂದು ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಹೊರಗಿಟ್ಕೊಂಡಿದ್ದೀನಿ. ಆ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಯಾವ್ದಾಗಿರುತ್ತೆ? ನಿಮ್ಮ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಇಂದ ಆಗಿರುತ್ತೆ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಈ ನೋಟಿಫಿಕೇಶನ್ ನೋಡ್ಕೋಬೇಕು. ಇದೇ ರೀತಿನ ನಾವು ಈಗ ಕ್ರಾಸ್ ಆಲ್ಡೋಲ್ ಕೂಡ ನೋಡ್ತೀವಿ. ಓಕೆ, ಅಲ್ಲಿ ನಾನು ಜಾಸ್ತಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಲ್ಲ. ಸೊ ಯು ಶುಡ್ ಬಿಲ್ಡ್ ಅಪ್ ಯುವರ್ ನಾಲೆಜ್ ಇನ್ ದೀಸ್ ರಿಯಾಕ್ಷನ್ ಇಟ್ ಸೆಲ್ಫ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ನೌ ಲೆಟ್ ಮಿ ಟಾಕ್ ಅಬೌಟ್ ಮೈ ಕೀಟೋನ್. ಇಲ್ಲಿ ಕೀಟೋನ್ ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ಬೇಕು? ಆಲ್ಡಾಲ್ ಅಥವಾ ಕೀಟೋಲ್ ಕಂಡೆನ್ಸೇಷನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ, ರಿಮೆಂಬರ್ aldol condensation is a common name we use. Okay, aldol condensation ಅಲ್ಲಿ we are using, as I mentioned, aldehydes ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ketones ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ketones ಯೂಸ್ ಮಾಡಿದಾಗ ಕೀಟೋಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆದ್ರೆ ಎಲ್ಲೂ ನಾವು ಕೀಟೋಲ್ ಕಂಡೆನ್ಸೇಷನ್ ಅಂತ ನೋಡೋಲ್ಲ. aldol condensation ಅಲ್ಲಿ ಎರಡೂನು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಬಟ್ ಯು ರಿಮೆಂಬರ್, ಕೀಟೋನ್ಸ್ ನ ಮಾಡಿದಾಗ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಬರೋದು ಕೀಟೋಲ್ ಪ್ರಾಡಕ್ಟ್ ಆಗಿರುತ್ತೆ ವಿನಃ ಆಲ್ಡಾಲ್ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲ. ಯಾಕೆ ಕೀಟೋಲ್ ಆಗಿರುತ್ತೆ? ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್, ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ketone group. ನೋಡೋಣ. ಸೊ ಫಸ್ಟ್ ಏನ್ ಬೇಕು ನಮ್ಗೆ? ಕ್ಯಾನ್ ಐ ಟೇಕ್ ಅಸಿಟೋನ್? CH3 C double bond O CH3. So this is my alpha, this is my alpha. Both are alpha, are having an alpha hydrogen atoms, so not an issue. ಸೊ ಇದನ್ನ ಹೇಗೆ ಇನ್ನೊಂದು ಮೋಲ್ ನ ಯಾವ ತರ ಬರ್ಕೊಂತೀನಿ? ಒಂದು ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ನ ಹೊರಗಿಟ್ಕೊಂಡು ಬರೆಯೋಣ. ಸೊ ಇದನ್ನ ತಗೊಂಡಾನ, ಒಂದು ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಹೊರಗೋದ್ರೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? CH2 C double bond O CH3. Nothing difference I have made. First as it is I have written. Next ಅದೇ ಕಂಪೌಂಡ್ ಅದ್ರ ಜೊತೆನೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಯಾವ ತರ? ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಅಲ್ವಾ? ಸೊ ಇವಾಗ ಏನಾಗುತ್ತಾ ಉಂಟು, ಇದು ಯಾಕೆ ಹಿಂಗ ಆಗ್ತಾ ಉಂಟು ಅನ್ನೋದು ನೀವೇ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಹೈಲಿ ಅಸಿಡಿಕ್. ಇದನ್ನ ನಾನೀಗ ಬೇಸ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡೋಣ. ಬೇಸ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡ್ತೀನಿ. ಲೆಟ್ ಮಿ ಟೇಕ್ ಇಟ್ ಆಸ್ ಅ ಡೈಲ್ಯೂಟ್ NaOH. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಆಸ್ ಐ ಮೆನ್ಷನ್, ಈ ಹೆಚ್ಚು ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಉಂಟು, ಇದೀಗ ಇಲ್ಲಿಗೆ ಬಂದು ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಏನ್ ಬರುತ್ತೆ ನೋಡ್ಕೊಂಡ್ರೆ, CH3 ಬರ್ದೆ, ಸಿ ಉಂಟು, ಸಿಂಗಲ್ ಬಾಂಡ್ OH. ಸೊ ಡಬಲ್ ಬಾಂಡ್ O ಇದ್ದು H ನ ಎಳ್ಕೊಂಡು ಸಿಂಗಲ್ ಬಾಂಡ್ OH ಆಯ್ತು. ಆಸ್ ಯೂಶುವಲ್ ಫಸ್ಟ್ ಇದನ್ನ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಕೊಂಡು CH3. ಈ ಹೆಚ್ಚು ಇಲ್ಲಿಗೆ ಹೋಯ್ತು, ಮಿಕ್ಕಿದ ಯಾವ್ದು? ಈಗ ಈ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ಅದನ್ನ ಬರೆಯತ್ತಿಗೆ ನೋಡ್ಕೊಳ್ಳಿ. ಯಾವ ತರ ಬರೀತಿದ್ದೀನಿ ನಾನು? CH2 ಈ ತರ ಬರ್ಕೊಂತೀನಿ. ಯಾಕೆ ಈ ತರ ಬರ್ಕೊಂಡೆ? ನಾನು ಇದನ್ನ ಹೀಟ್ ಮಾಡಿದಾಗ ನನ್ನ ಹೈಡ್ರೋಜನ್ ಹೋಗುತ್ತಲ್ಲ, ಅವಾಗ ಬಾಂಡ್ ನ ತೋರಿಸಬಹುದು ಈಸಿಯಾಗಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇನ್ನೇನು ಉಳ್ಕೊಂಡಿದೆ? C double bond O CH3. ಎಸ್ ಆರ್ ನೋ? ನಥಿಂಗ್ ಮಚ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀರಾ? ಈಗ ಇದನ್ನ ಹೀಟ್ ಮಾಡೋಣ. ಹೀಟ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು? OH ಇಸ್ ಗೋಯಿಂಗ್ ಔಟ್, H ಪ್ಲಸ್ ಇಸ್ ಕಮಿಂಗ್ ಔಟ್. ಸೊ ಅವಾಗ ಇದ್ರದ್ದು ವೇಲೆನ್ಸಿ ಕಮ್ಮಿ ಆಯ್ತಲ್ಲ, ಯಾಕಂದ್ರೆ OH ಮೈನಸ್ ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು. ಸೊ ಇದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ ಏನ್ ಮಾಡುತ್ತೆ? ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂಡು ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಅದ್ ಬಂದಾಗ ಏನಾಯ್ತು? H ಪ್ಲಸ್ ಇಸ್ ಮೂವಿಂಗ್ ಔಟ್. ಸೊ H ಪ್ಲಸ್ OH ಮೈನಸ್ ಗಿವ್ಸ್ ಯು ಮೈನಸ್ H2. ದಟ್ ಇಸ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹ್ಯಾಸ್ ಗಾನ್ ಔಟ್. ಕಂಡೆನ್ಸೇಷನ್ ಪ್ರಾಡಕ್ಟ್ ಬರ್ತಾ ಉಂಟು. ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಬರೇನ್ವೆ? CH3 ಉಂಟು, CH3 ಉಂಟು. So you should take uttermost care guys when you are writing. C untu. Next I will write my CH3 over here. ಅಲ್ವಾ? ಯಾಕೆ ಇಲ್ಲಿಗ ಡಬಲ್ ಬಾಂಡ್ ಬರುತ್ತೆ. ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ನಂಗೆ ಬರೆಯಕ್ಕೆ ಈಸಿ ಆಗ್ಲಿ ಅಂತ. ಈಗ ಡಬಲ್ ಬಾಂಡ್ ಆಯ್ತು. ಇನ್ನೇನು ಉಳ್ಕೊಂಡಿದೆ? ಇ ಸಿ ಉಳ್ಕೊಂಡಿದೆ. ಈ ಹೆಚ್ ಇಲ್ಲ, ಈ ಹೆಚ್ ಉಂಟು. ಸೊ ಇಲ್ಲಿ ಹೆಚ್ ಉಂಟು. ಸ್ಟಾಪ್ ಆಗ್ಲಿಲ್ಲ. ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಉಂಟು, ಇದನ್ನು ಬರ್ಕೊಂಡೆ. CH3 ಉಂಟು. Can you see? So can you see how the difference is with respect to ketone and that of your aldehyde? But the process is same. So you should pay uttermost attention when you're writing these products. Okay? Product ಜಾಸ್ತಿ ಕಾಣ್ಬಾರ್ದು. ನೋಡಿ ಎಷ್ಟು ಈಸಿಯಾಗಿ ನಾವು ಇದನ್ನ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ. It only comes by practice. So you can only practice by taking any of your alpha hydrogen atom ಇರೋ aldehyde or ketones. ಅಲ್ಲಿ ಅಸಿಟೋನ್ ತಗೊಂಡಿದ್ದೀನಿ, ನೀವು CH3, CH2, COCH ತಗೊಳ್ಳಿ, ಪ್ರೊಪೆನೋನ್ ತಗೊಳ್ಳಿ. ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರತ್ತ ತಗೋಬೇಕಷ್ಟೇ. ಆಲ್ಡೋಲ್ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, ಅದೇ ಆಲ್ಡಿಹೈಡ್ ಅದೇ ಕೀಟೋನು ತನ್ನಂಗಿದೆ ಇನ್ನೊಂದು ಕೀಟೋನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು ಬೈ ಯುಟಿಲೈಸಿಂಗ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಬೇಸ್. ಬೇಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಈ ಹೈಡ್ರೋಜನ್ ಹೋಗ್ಬೇಕು ಹೊರಗಡೆ, ಅವಾಗ ಮಾತ್ರ ಈ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಇರೋದು. ಸೊ ಯು ಶುಡ್ ಪೇ ಈಚ್ ಅಂಡ್ ಒನ್ ವರ್ಡ್ ಓವರ್ ಹಿಯರ್ ಇಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಪೇ ಅಟೆನ್ಷನ್. ಸೊ ಇದೇನಾಗುತ್ತೆ, ಇದೀಗ ಕೀಟೋನ್ ಅಲ್ವಾ, ಇದು ನನ್ನ ಗ್ರೂಪ್, ಅದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಆಲ್ಫಾ, ದಿಸ್ ಇಸ್ ಮೈ ಬೀಟಾ. ಸೊ ಏನ್ ಹೇಳ್ಬೋದು, ಇದನ್ನ ಬೀಟಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್ ಅಂತ ಹೇಳ್ಬೋದು. ಹೋದ್ ಸರಿ ಏನಂದೆ, ಆಲ್ಡಿಹೈಡ್ ಅಂತ ಹೇಳಿದೆ. ಯಾಕೆ ಅಲ್ಲಿ ಆಲ್ಡಿಹೈಡ್ ಗ್ರೂಪ್ ವಾಸ್ ಎ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಕೀಟೋನ್. ಸೊ ಬೀಟಾ ಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್. ವಾಟರ್ ಮಾಡಿದಾಗ ಏನ್ ಬಂತು ನಂಗೆ, ಆಲ್ಡಿಹೈಡ್ ತಗೊಂಡಾಗ ಆಲ್ಫಾ ಬೀಟಾ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಕಾರ್ಬೋನಿಲ್ ಕಂಪೌಂಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲೂ ಕೂಡ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದು ಕೂಡ ಕಾರ್ಬೋನಿಲ್ ಕಂಪೌಂಡ್ ಜನರಲ್ ಆಗಿ ಹೇಳಿದ್ದೇನೆ. ಸೊ ಆಲ್ಫಾ ಬೀಟಾ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಕಾರ್ಬೋನಿಲ್ ಕಂಪೌಂಡ್. ವೆರಿ ಮಚ್ ಈಸಿ ಅಲ್ಲ. ಡೋಂಟ್ ಗೆಟ್ ಪ್ಯಾನಿಕ್ ಬೈ ಸೀಯಿಂಗ್ ದಿಸ್ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ನ ನೋಡ್ಕೊಂಡು ಹೆದರ್ಕೋಬೇಡಿ. ಯಾವ ತರ ನಾವು ಬಂದ್ವಿ, ಎಷ್ಟು ಈಸಿಯಾಗಿ ಇದನ್ನ ಬರ್ದ್ವಿ ಅನ್ನೋದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಇನ್ನೊಂದ್ಸರಿ ಪಾಸ್ ಮಾಡಿ ವಿಡಿಯೋನ, ಪಾಸ್ ದಿ ವಿಡಿಯೋ, ಯು ಓನ್ಲಿ ಟ್ರೈ ಬೈ ಟೇಕಿಂಗ್ ಇಟ್ ಸೇಮ್ ಎಕ್ಸಾಂಪಲ್. ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಈಸಿ ಫಾರ್ ಯು. ಓಕೆ, ಎಲ್ಲಿ ಆಡ್ ಆಗ್ತಾ ಉಂಟು, ಎಲ್ಲಿ ವಾಟರ್ ನ ತೆಗಿತಿದ್ದೀನಿ, ಎಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಹೊರಗೆ ಹೋಗ್ತಾ ಉಂಟು, ಈಸ್ ಎವ್ರಿ ಮಚ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಅಲ್ಟಿಮೇಟ್ ಆಗಿ ನೋಡ್ಬೇಕು ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಬರೆದ್ಮೇಲೆ ಎಲ್ಲ ಕಾರ್ಬನ್ ಇಂದು ವೇಲೆನ್ಸಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಿದೆಯಾ, ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ವಿಲ್ ಬಿ ಕರೆಕ್ಟ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಯಾಕೆ ಇದನ್ನ ಆಲ್ಫಾ ಬೀಟಾ ಅಂದೆ, ದಿಸ್ ಇಸ್ ಮೈ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಆಲ್ಫಾ, this is my beta. So in between alpha and beta there is an unsaturated. So alpha beta unsaturated, what type of a compound it is? Carbonyl compound. So I have given a general name. You can give the IUPAC name also. Yav ತರ ಕೊಡ್ತೀರಾ, 1 2 3 4 5. So 5 methyl, yes, pent 3 in 2-one alva. 5 methyl pent 3 in 2-one will be your IUPAC name of this alpha beta unsaturated carbonyl compound. Able to understand the aldol condensation? So it's a condensation reaction basically, in which your aldehydes or ketones are reacting with dilute alkali, which is acting as a catalyst. Okay, which is abstracting a proton. To first of all, it gives you what? Beta hydroxy aldehyde in case if you have used an aldehyde, or beta hydroxy ketone if in case you have used a ketone, which on further heating the final product will be an alpha beta unsaturated carbonyl compound. Very much important. Okay, getting my point? So this was called as what? Aldol condensation. ಅಲ್ಲ, ಇಲ್ಲೇನ್ ಮಾಡಿದ್ವಿ ನಾವು, ಒಂದೇ ತರದ ಆಲ್ಡಿಹೈಡ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. I repeat, in this aldol condensation what we have done, we have only used one type of an aldehyde or a one type of a ketone. Alva? But the scientists are not so dumb. What they did, what if I take two types of aldehyde or two types of ketone? Are you getting my question? Now the next what the scientists did, instead of taking just one type of an aldehyde and a ketone, ಇಲ್ಲಿ ನೋಡಿ ನಾವು ರಿಯಾಕ್ಷನ್ ಮಾಡಿರೋದು ಯಾವುದು, ಆಲ್ಡಿಹೈಡ್ ಜೊತೆ ಆಲ್ಡಿಹೈಡ್, ಅದು ಕೂಡ L2 ಆಲ್ಡಿಹೈಡ್ ಸೇಮ್. ಇಲ್ಲೂ ಕೂಡ ಕೀಟೋನ್ ಯಾವುದು, ಅಸಿಟೋನ್ ಜೊತೆ ಟ್ರೀಟೆಡ್. ಈಗ ಕ್ವಶನ್ ಅರೈಸ್ ಆಯ್ತು, ನಾನು ಇಷ್ಟು ಸಿಂಪಲ್ ಮಾಡಲ್ಲಪ್ಪ, ನಂಗೆ ಒಂದ್ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಬೇಕು. ಏನ್ ಮಾಡ್ತೀನಿ ನಾನು, ಲೆಟ್ ಮೀ ಚೂಸ್ ಓಕೆ ಎಥೆನಾಲ್ ವಿತ್ ಪ್ರೊಪೆನಾಲ್. So I'm choosing two different aldehydes and both the aldehydes are having what? Alpha hydrogen atom. I will not keep quiet now. Let me take ethanone with propanone. ethanone with propanone, two different ketones which is having alpha hydrogen atoms. Once again, I will not be quiet. I will be using now, for example, I can choose as what? Benzaldehyde with benzophenone. So what is the observation in my third example? This is not having the alpha hydrogen. Benzaldehyde is not having the alpha hydrogen, whereas benzophenone is having the alpha hydrogen. So ee tara three cases na ಈಗ ನಾವು study ಮಾಡಕ್ ಹೋಗ್ತಾ ಇರೋದೇ under the heading called as cross aldol condensation. Cross aldol condensation. ಅಲ್ವಾ? ಹೆಸರು ಚೆನ್ನಾಗುಂಟು. ಯಾವತ್ತೇ ಏನೋ ಡಿಫಿಕಲ್ಟ್ ಟಾಸ್ಕ್ ಬಂದ್ಕೊಳ್ಳೆ ವಿಲ್ ಕೀಪ್ ಅವರ್ ಹ್ಯಾಂಡ್ ಲೈಕ್ ದಿಸ್ ಕ್ರಾಸ್. Yes or no? So that would be done very easily. The same you can think in that way. It's not chemistry. I'm just giving you the hint. So it's somewhat difficult, but not so difficult. If you have understood how to write this aldol, it will be very easy to solve this cross aldol also. So that is the reason I said pay attention when we are doing this aldol condensation. So cross aldol condensations are the reaction in which we are going to react two different aldehydes or ketones. Mark my words, two different aldehydes or ketones. And the interesting fact, what is that? If your two different aldehydes or ketones, if both are having the alpha hydrogen atoms, mark my words, if you are using an aldehyde and an aldehyde, first case, okay, and if you are using ketone and another ketone, okay, these are all different. This is one aldehyde, this is another aldehyde, this is one ketone, this is another ketone, okay. And the third case, if you are using aldehyde and a ketone, and in all these cases, if both of these reactants are having the alpha hydrogen atom, ಯಾವ reactant ನಾವು ಯೂಸ್ ಮಾಡಿದೀವಲ್ಲ cross aldol ಅಲ್ಲಿ, two different aldehydes, two different ketones, or an aldehyde and a ketone, if all these are having an alpha hydrogen atom, we would be getting four different products. Interesting, very much interesting if you pay attention, and if you think that you have to study it and understand it, it will be very, very interesting. Okay, ಯಾಕೆ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಕೆಮಿಸ್ಟ್ರಿ ಅನ್ನೋದು ಇದ್ರಲ್ಲಿ ನಾವು ಅತಿ ಬೇಗನೆ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಏನ್ ಮಾಡ್ಬೇಕಂತ ಇರ್ತೀವಿ, ಅಲ್ಲಿ ಏನ್ ಆಗ್ತಾ ಉಂಟು ಅಂತ ಸ್ಟಡಿ ಮಾಡೋದು ನಿಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿದ ಮೇಜರ್ ಸರ್ಪ್ರೈಸಿಂಗ್ ಟರ್ಮ್ಸ್. ಓಕೆ, ಸೊ ರಿಮೆಂಬರ್, whenever you are doing a cross aldol condensation reaction and in your reactants you are chosen in such a way that if your reactants, both the reactants are having the alpha hydrogen atom, we would be getting four different products. But in case if it is having alpha hydrogen atom and another is not having an alpha hydrogen atom, of course you will be getting just one type of a product. So we will study it one by one with examples under the topic of your cross aldol condensation. Okay, let's have a look at it. So guys, first let me talk about cross aldol taking two different aldehydes, mark my words, two different aldehydes, and both the aldehydes are having the alpha hydrogen atoms. Very much important and interesting. Have a look at it. Okay, so first we are going with aldehyde reacting with an aldehyde, and both the aldehydes are having an alpha hydrogen atoms. Okay, so first of all let me choose CH3CH, which is ethanol, plus CH3CH2CHO, which is propanol. Of course, this is my ethanol, this is my propanol. Both are different aldehydes, and what is the common thing? Both the aldehydes are having an alpha hydrogen atoms. Alpha hydrogen atoms ಅಂದ್ರೆ ಅರ್ಥ ಏನು? The hydrogen atom which is bonded to the alpha carbon atom. ಅಲ್ವಾ? ಇಲ್ಲೂ ಕೂಡ alpha carbon atom ಉಂಟು, ಇಲ್ಲೂ ಕೂಡ alpha carbon atom ಉಂಟು, and both the carbon atoms are having their respective hydrogen atoms. So both the aldehydes are having an alpha hydrogen atom. Of course, I have said, so whenever you are choosing such a reactants in which both they are having the alpha hydrogen atom, instead of getting a single product, now we are going to get four different products. Why is it so? Let us see through it. Of course, I have used two reactants. But see, the reactant, instead of we should play with the reactants will play with us. How, sir? Yes. First ಏನು ಮಾಡುತ್ತೆ, ಇವೆರಡು ರಿಯಾಕ್ಟ್ ಆಗಲ್ಲ. ಏನಾಗ್ತಾ ಉಂಟು, ಫಸ್ಟ್ they will not react. What they will do instead, first ethanol will react with ethanol itself, as we have seen in the aldol condensation. Mark my words, ethanol will react with ethanol itself. Propanol will react with propanol itself. Then what happens, ethanol will attack propanol. Then what happens, propanol will attack ethanol. Confusing? Don't get confused, we'll go through it. First ಏನಾಗುತ್ತೆ, of course this is my reaction, I am treating it in the presence of dilute NaOH. Of course ಈಗ ನಾವೇನ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ವಿ, aldol condensation ಅಲ್ಲಿ ಯಾವತ್ತೇ ಒಂದು ಆಲ್ಡಿಹೈಡ್ ಅಥವಾ ಕೀಟೋನ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಅದು aldol condensation ಆಗೇ ಆಗುತ್ತೆ. ಇದು ಹೆಸರು ಕ್ರಾಸ್ aldol ಇರಬಹುದು, ಆದ್ರೆ ಏನಾಗಿದೆ ಇಲ್ಲಿ, both are having the alpha hydrogen atom. So first what they will do, they will undergo aldol condensation. That means what, the alpha aldehydes or ketones, alpha hydrogen containing aldehyde, they will react with themselves first. So first ಏನಾಗುತ್ತೆ, CH3 C double bond OH. Yes, it will react with itself first. That is, ethanol will react with ethanol itself. See how they are playing culprit fellows. Yes, in the presence of dilute NaOH. ಅಲ್ವಾ, OH minus ಅಂತ ಬರ್ಕೊಂತೀನಿ. As we have seen earlier, ಈ H ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಈ CH2 ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. So CH3 COH CH2 CHO. Yes, then I am just one H is I have missed over here. Then minus H2O on heating. So ಏನಾಗುತ್ತೆ, ಈ OH ಹೋಗುತ್ತೆ, ಇಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. So CH3, let me write it over here itself so it will be easy. So CH3 CH double bond CH single bond CHO. Yes or no? So what is its name? 1 2 3 4 alva. So I can call it as a but-2-enol. So this was when, mark my words, mention the, I am writing the product so that you should be aware that what type of a products you are getting. Okay, ಇದು ಯಾವಾಗ ಆಯ್ತು, when ethanol is undergoing an aldol condensation. ಅದೇ ರೀತಿ ಈಗ ಇನ್ನೊಂದು ಆಲ್ಡಿಹೈಡ್ ಯಾವುದು ಉಂಟು, ಪ್ರೊಪೆನಾಲ್, ಅದರಲ್ಲೂ ಕೂಡ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಉಂಟು. ಸೊ ಆಫ್ ಕೋರ್ಸ್ ಇಟ್ ವಿಲ್ ಆಲ್ಸೋ ಅಂಡರ್ಗೋ ನೌ aldol condensation first. So let me go on with it. CH3 CH2 C double bond OH, it will react with the acidic proton of itself. That is CH2 CH2. ಈ ಹೆಚ್ಚು ಎಲ್ಲಿಂದ ತೆಗೆದಿದ್ದೀನಿ ನಾನು, ಇಲ್ಲಿಂದ ತೆಗೆದಿದ್ದೀನಿ. Okay, that is acidic. So guys, now we have to see for this one alwa. Propanol is reacting with the propanol. Here I made a mistake over here. What was the mistake? As I mentioned, I have to use the acidic proton. But of course, when I am writing for, it was easy for when I was writing for an ethanol. Ethanol ಏನಾಯ್ತು, ಇದು acidic proton ಆಗಿರುತ್ತೆ, ಯಾಕಂದ್ರೆ adjacent ಇದೆ. ಆದ್ರೆ ಇಲ್ಲೇನಾಯ್ತು, ನಾನು ಇಲ್ಲಿಂದ ತಗೊಂಡ್ರೆ, that was wrong. You have to take the acidic proton from this carbon. Able to understand? So how can I write it? CH3 will remain as such. Here you will be having H. Here you will be having H. This CHO. So ಈ ಆಕ್ಸಿಜನ್ ಗೆ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಹೋಗಿ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು, ಈ ಒಂದು ಪ್ರೋಟಾನ್ ಹೋಗಿ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಸೊ ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಯೋರ್ ಡೈಲ್ಯೂಟ್ OH minus CH3 CH2 COH. mark my words, here comes H. ಈ ಕಾರ್ಬನ್ ಅಟ್ಯಾಕ್ ಆಗಬೇಕು, ದಿಸ್ ಕಾರ್ಬನ್, ನಾಟ್ ದಿಸ್, ಇನ್ಸ್ಟೆಡ್ ದಿಸ್ ಕಾರ್ಬನ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ C, ಎಸ್, ಒಂದು CH3 ಉಂಟು, ಒಂದು H ಹಾಗೇನೆ ಉಂಟು, and here comes our CHO. Yes or no? So ಇದನ್ನ ನಾನೀಗ ಹೀಟ್ ಮಾಡ್ತೀನಿ ಅಂದಾಗ this will go out. Yes or no? This will come as a H plus, so this will form a bond. So if I am going to write, I would be getting as a CH3 CH2 single bond C, which is having a H, double bond C, single bond CH3 and a CHO. So what is the name of this product? You can say 1 2 3 4 5. Yes, so 2-methyl, yes, pent-2-enol. What I am trying to say over here, when you have chosen an aldehyde, that is your ethanol reacting with a propanol, under the dilute NaOH, first ethanol will undergo aldol condensation. That is, it is going to react with itself. So at that moment you got one type of a product, that was but2-enol. Of course, propanol is also having an alpha hydrogen atom, so it will also undergo aldol condensation. So you'll be getting a product as what? 2-methyl pent-2-enol. ಅರ್ಥ ಆಗ್ತಂದ್ರೆ 2 ತರದ ಪ್ರಾಡಕ್ಟ್ ಸಿಗ್ತಾ ಉಂಟು. ಇನ್ನು 2 ಉಳಿದಿದೆ, ಅದು ಯಾವ ತರ? ಈಗೇನಾಗುತ್ತೆ, CH3CHO ಉಂಟಲ್ವಾ, it is now going to react with the acidic proton of your propanol. ಯಾವ ತರ? CH3 acidic proton ಅಂದ್ರೆ ಯಾವುದು? ಇದು C. ಇವೆರಡು ಪ್ರೋಟಾನ್ ಏನಾಗಿರುತ್ತೆ? ಅಸಿಡಿಕ್ ಇರುತ್ತೆ. ವೈ? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಅಡ್ಜಸೆಂಟ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ ಆಲ್ಡಿಹೈಡ್. ಸೊ ನೋ ಆಲ್ಡಿಹೈಡ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈಗ ಈ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಲೆಟ್ ಮಿ ರೈಟ್ ಇಟ್ ಡೌನ್ವರ್ಡ್ಸ್. ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ OH ಮೈನಸ್. ಸೊ ಏನಾಗುತ್ತೆ ಅವಾಗ? CH3COH. Here comes H. Yes. So now what happens? ಈ H ಇಲ್ಲಿಗೆ ಹೋಯ್ತು, ಈ ಕಾರ್ಬನ್ ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಉಂಟು. Not this carbon, this carbon. So now you will be having over here as a C. Yes, CH3. ಈ H ಹೋಗಿದೆ, ಒಂದ್ H ಉಳ್ಕೊಂಡಿದೆ, ಡಬಲ್ ಬಾಂಡ್ H. Yes or no? And overall CHO. Yes. Now on heating this one, this will go out. Let me write like this H. Okay. ಇದೇನ್ ಮಾಡುತ್ತೆ? ಇಲ್ಲಿಗೆ ಕೊಡುತ್ತೆ. So you'll be getting the final product as CH3CH double bond C single bond CH3CHO. So what type of product it is? 1, 2, 3, 4. Yes. So this is called as what? Sorry, 2-methyl but 2-enol. 2-enol. Can you get the difference? So first ಏನ್ ಬಂತು ನಂಗೆ? but2-enol ಬಂತು, one type of a product. Second 2-methyl pent-2-enol ಬಂತು. ಹೀಗೇನ್ ಬರ್ತಾ ಉಂಟು? 2-methyl but2-enol. ಸೊ ಇದು ಮೂರನೇ ಪ್ರಾಡಕ್ಟ್. ಅಗೇನ್ ಇಲ್ಲೇನಾಯ್ತು? ಪ್ರೊಪೆನಾಲಿನ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಎಥೆನಾಲಿಕ್ ಅಟ್ಯಾಕ್. ಈಗ ಏನಾಗುತ್ತೆ? ಉಲ್ಟಾ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ CH3CH2 C double bond O and H plus yes HCH2CH. ನಾವು ಎಥೆನಾಲ್ ಈಸಿ ಅಲ್ವಾ, ಅದು ಅಡ್ಜಸೆಂಟ್ ಇರೋದೇ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಸೊ ಇದು ಅಟ್ಯಾಕ್ ಆದಾಗ ಏನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ? ಓಕೆ, ದಿಸ್ ಇಸ್ ಅನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ OH ಮೈನಸ್ CH3CH2 COH. H is there. This carbon is attacking, so CH2CHO. On heating, this will go out, this will come out, this will form a double bond. So CH3CH2 CH. Okay, this is complete double bond C. EH ಹೋಗಿದೆ, ಒಂದು H ಉಳ್ಕೊಂಡಿದೆ, double bond CH, single bond CHO. So no. So what type of a product it is? 1, 2, 3, 4 and a 5. Yes. So pent-2-enol. Pent-2-enol. So let me write the first product. First ಏನ್ ಬಂತು ನಿಮಗೆ? but2-enol. Second ಏನ್ ಬಂತು ನಿಮಗೆ? It was actually 2-methyl pent-2-enol. Third ಏನ್ ಬಂತು ನಮಗೆ? 2-methyl but2-enol. Fourth ಏನ್ ಬಂತು ನಮಗೆ? pent-2-enol. So ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬಂತು ನಮಗೆ? 4 types of product you are getting. Are you able to understand what I try to say? So whenever we are using an aldehyde or a ketone, okay, I have just given an example for aldehyde. You can try by yourself with respect to the ketone also. So whenever you are using an aldehyde or a ketone, okay, and both the reactants, if they are having the alpha hydrogen atom, they are giving you how many types of products? 4 different products. Why? Because first, it may be aldehyde or a ketone, first they will undergo self aldol condensation. ಅದು ಅದ್ರ ಜೊತೆನೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಅವಾಗ ಆತರ ಆದಾಗ ಏನಾಗುತ್ತೆ? 2 ಪ್ರಾಡಕ್ಟ್ ಸಿಗ್ತಾ, ಒಂದು ಆಲ್ಡಿಹೈಡ್ ಅದರ ಆಲ್ಡಿಹೈಡ್ ಜೊತೆನೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಆಲ್ಡಿಹೈಡ್ ಅದರ ಆಲ್ಡಿಹೈಡ್ ಜೊತೆನೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ದೆನ್ ಏನಾಗುತ್ತೆ? ಒಂದು ಆಲ್ಡಿಹೈಡ್ ಇನ್ನೊಂದು ಆಲ್ಡಿಹೈಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಆಲ್ಡಿಹೈಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಇಟ್ ಇಸ್ ಕನ್ಫ್ಯೂಸಿಂಗ್ when I am saying, but when you write it you will come to know. Okay, first ethanol reacted with ethanol itself, then propanol reacted with propanol itself. it will undergo aldol condensation. Then it will undergo cross aldol. Yav ethanol will react with propanol. Then afterwards, propanol will react with ethanol. So like the series, you'll be getting 4 different types of products. So that is the reason they have said. So whenever you are undergoing cross aldol condensation and you have used an aldehyde and an aldehyde, a ketone and a ketone, or aldehyde and a ketone, in these 3 cases, if both the reactants are having the alpha hydrogen atom, you will be getting 4 different products. Clear? ಅದೇ ರೀತಿ ನಾನು ಇನ್ನೊಂದೇನು ಹೇಳಿದೆ, ಈಗ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಅಲ್ಲಿ ಮಾತ್ರ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದ್ದಿದ್ರೆ ಏನಾಗೋದು, ಓನ್ಲಿ 1 ಪ್ರಾಡಕ್ಟ್ ಬರೋದು. ಲೆಟ್ ಅಸ್ ಗೋ ವಿತ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, ಏನ್ ಹೇಳಿದ್ದಾರೆ, ಬೆನ್ಜಾಲ್ಡಿಹೈಡ್. ಸೊ ಹೌ ಕ್ಯಾನ್ ಐ ರೈಟ್ ಬೆನ್ಜಾಲ್ಡಿಹೈಡ್ ಲೈಕ್ ದಿಸ್? ಇಫ್ ಐ ಚೂಸ್ C double bond O H, you can just see that it is not having the alpha hydrogen atom. I repeat, it is not having the alpha hydrogen atom, but it is reacting with benzophenone, that is C6H5 CHO CH3. So this is my acidic proton alva. So acidic proton jotene react agbekadu. So this is my what, benzophenone or acetophenone alva, C6H5 CO CH3. So idu iga alpha hydrogen atom. Carry out the reaction in the presence of first dilute alkali. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಫಸ್ಟ್ COH EH ಹಾಗೇನೆ ಇರುತ್ತೆ. ಇಲ್ಲೇನಾಯ್ತು, CH2 ಬರುತ್ತೆ. ಇಲ್ಲಿ C double bond O C6H5. Let me write my benzene ring as C6H5. Then on heating this one, what happens? This will go out. This will form a double bond. So C6H5. Okay, this part. Then C is there, H is there, double bond is there, C is there, H is there, single bond is there, C double bond O C6H5. So what is its name? Is actually, it will be called as a benzyl acetophenone. Common name, if I give it a IUPAC name, 1,3 diphenyl 1,3 diphenyl prop 2-in-1-one 2-in-1-one. Is that clear? Getting, so only 1 type of a product is open. Why I have got 1 type of a product? Because whatever the reactant I have used, it is only having, 1 reactant is only having the alpha hydrogen atom. So acidic proton adu matra kodutte, that will carry out the reaction to give only 1 product. If both their reactants were having the alpha hydrogen atom, you would have obtained 4 different products. And that is the greatest example what we have dealt over here. Is that clear? Very much important for your competitive point of view. Okay, most of the cases in a cross aldol, they will only ask this type, in which one of the product will be one of the reactant will be having the alpha and another will not be having. And do remember, this type of reactions are very much familiar in cross aldol, because when you are taking like this, that is both the reactants are having the alpha hydrogen atom, you will be getting a 4 different products. Aduna separate ಮಾಡುದು, separation is quite a difficult task. Okay, though we are getting 4 different types of the product, the separation is difficult task. So we'll only opt those product which will be having the alpha hydrogen atom and which is a better undergo a nucleophilic addition reaction. Okay, so generally cross aldol alli ನಾವು ಈ ತರ reaction ne what we can give, we give the importance. Is that clear? But you have to understand just one important thing. What is that? Aldol and cross aldol ಎರಡು ಆಗಬೇಕು ಅಂದ್ರೆ it should have an alpha hydrogen atom, first important thing, and it should undergo in the presence of dilute alkali. Difference ಏನು ಅಂತ ಕೇಳಿದ್ರೆ, aldol ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, ಆ ಆಲ್ಡಿಹೈಡ್ ಅದ್ರ ಜೊತೆನೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಆದ್ರೆ ಕ್ರಾಸ್ aldol ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, we can treat 2 different aldehydes or a ketones or an aldehyde with a ketone, in which at least, I am saying, mark my words, at least in a cross aldol, at least one of the reactants should have the alpha hydrogen atom. At least. At most, both can have. Yes or no? That we have seen over here. Is that clear? I hope so. There is no doubt. You can try with an example. Let me give you an example for ketone. CH3 C double bond O CH3 is reacting with CH3 CH2 C double bond O C. Let me give you as CHO. No, sorry, CH3. CH3 CH2 CO CH3. Can you please give the products? If it undergoes cross aldol condensation, what type of a product you can obtain? ಎಷ್ಟು product ಬರಬೇಕು? Yes, good. 4 different types of the product you should get. Okay, try it once and you can give the answers in your comment section. Okay, but do remember, both are having the alpha hydrogen atom, so you should get what? 4 different products. Clear? I hope so there is no doubt. ಇಲ್ಲಿ ನೀವು ಯೋಚನೆ ಮಾಡಬೇಕು, ಇಲ್ಲೂ ಕೂಡ ಆಲ್ಫಾ, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಆಲ್ಫಾ. ಓಕೆ, ಈ ಹೈಡ್ರೋಜನ್ ಬಿಟ್ಕೊಡುತ್ತೋ, ಈ ಹೈಡ್ರೋಜನ್ ಬಿಟ್ಕೊಡುತ್ತೋ. ಆಫ್ ಕೋರ್ಸ್ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತು, ವೆನ್ ಎವರ್ ಅನ್ ಅಸಿಡಿಕ್ ಪ್ರೋಟಾನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಔಟ್, ಇಟ್ ವಿಲ್ ಬಿ ಫಾರ್ಮಿಂಗ್ ಫಸ್ಟ್ ಕಾರ್ಬ್ಯಾನಯೋನ್. ಇಸೋನೋ ಕಾರ್ಬ್ಯಾನಯೋನ್. ಇಲ್ಲಿ ಬಿಟ್ಕೊಟ್ರೆ ಪ್ರೈಮರಿ ಕಾರ್ಬ್ಯಾನಯೋನ್, ಇಲ್ಲಿ ಬಿಟ್ಕೊಟ್ರೆ ಸೆಕೆಂಡರಿ ಕಾರ್ಬ್ಯಾನಯೋನ್. ಇಸೋನೋ ಹಾ. ಸೊ ಯು ಶುಡ್ ಓನ್ಲಿ ನಾವು ಅಟೆಂಪ್ಟ್, ಈಗ ನೀವು ಥಿಂಕ್ ಮಾಡಬೇಕು, ಪ್ರೈಮರಿ ಕಾರ್ಬ್ಯಾನಯೋನ್ ಸ್ಟೇಬಲ್, ಸೆಕೆಂಡರಿ ಕಾರ್ಬ್ಯಾನಯೋನ್ ಸ್ಟೇಬಲ್. So depending upon those factors, you will be getting the product. So you should apply somewhat mind over here. I'm giving you the hint. It depends upon what type of a carbanion it is forming. Okay. Of course it is a confusing one, but not so confusing. You should understand the concept behind it. ಅದಕ್ಕೆ ನಾವು ಫಸ್ಟ್ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಹೋದಾಗ ಏನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಫಸ್ಟ್ ಹೇಳಿದೀನಿ. ಕಾರ್ಬ್ಯಾನಯಾನ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ಕಾರ್ಬ್ಯಾನಯಾನ್ ಫಾರ್ಮ್ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಇಲ್ಲಿ ಈಗ ಎರಡು ತರದ ಕಾರ್ಬ್ಯಾನ್, ಇಲ್ಲಿ ಪ್ರೈಮರಿ, ಇಲ್ಲಿ ಸೆಕೆಂಡರಿ. So you should understand that what type it will undergo. Okay. So depending upon that one, you just give your products. Clear? No doubt. Okay. So next important part, the final reaction we are going to study, which is called as what? Cannizzaro reaction. I have repeated it. Cross aldol ಮತ್ತೆ aldol. Our reaction ಅಲ್ಲಿ aldol alpha hydrogen atom was required. So of course now the scientists were scratching their head whether it is possible to carry out the reaction in the alkali medium between the aldehydes without alpha hydrogen atoms. I repeat, without alpha hydrogen atoms. And there they came across with a reaction which itself was called as Cannizzaro reaction. Cannizzaro reaction. So let's have a look at this reaction now. So guys, Cannizzaro reaction is quite simple when compared to that of your aldol and a cross aldol condensation. ಇಲ್ಲೇನಾಗುತ್ತೆ ಅಂದ್ರೆ basically whenever you have to apply the Cannizzaro reaction, or we can say that this Cannizzaro reaction takes place with respect to the aldehydes and the ketones which are not having, or we can say more particularly aldehydes which are not having the alpha hydrogen atoms. Aldehydes which are not having the alpha hydrogen atoms, because ketones ಅಲ್ಲಿ alpha hydrogen atom ಬಂದೇ ಬರುತ್ತೆ. So this is mainly employed for the aldehydes which are not having the alpha hydrogen atoms, which are not having the alpha hydrogen atoms. Yes, so let us talk about it now. Okay, so ಏನಾಗುತ್ತೆ, of course ನಮ್ಗೆ ಇದರಲ್ಲಿ ಈಗ ಆಲ್ಕಲಿ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಬೇಕು, ಆದ್ರೆ ಇಲ್ಲಿ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇಲ್ಲ. ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೂ ಕೂಡ ಅರ್ಥ ಏನು, ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಅನ್ ಅನದರ್ ಹೈಡ್ರೋಜನ್. ಫಾರ್ example for aldehydes which are not having the alpha hydrogen atom is HC double bond OH, formaldehyde. As I mentioned with respect to the aromatic system, your benzaldehyde. So ಇವೆರಡರಲ್ಲೂ ಈಗ ಏನಾಗಿದೆ, ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇಲ್ಲ ಅಲ್ವಾ, ಇದಕ್ಕೆ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲ, ಇದಕ್ಕೂ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ವಾಸ್ ನಾಟ್ ದೇರ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ದೇ ಆರ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ದಿ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಓಕೆ, ಸೊ ಏನಾಗುತ್ತೆ, remember, in order to carry out this reaction we would be requiring a strong solution of NaOH. What? Strong solution of NaOH, or sometimes you can also use KOH. But what is the main thing? We have to use strong, because they are not in the need, or they are not very enthusiastic to give their proton. So ಈಗ ನಾವು forcefully ತೆಗಿಬೇಕು. So forcefully ತೆಗಿಬೇಕು ಅಂದ್ರೆ higher force should be applied. So that is the reason we are using strong. So now let us see what happens. So remember guys, whenever you are treating your aldehydes, okay, it's a general thing you should remember, whenever we are treating your aldehydes with a strong solutions of your alkali, for example KOH, so you will be getting what? Two products. You will be getting a mixture of products, we can say. One will be an alcohol and another will be a sodium salt of a carboxylic acid. Let me talk about it. So here you will be getting as HCH3OH plus HC double bond O and a O plus K minus. So ಏನಾಯ್ತು, when formaldehyde was treated with a strong alkali, your potassium hydroxide, we are getting a mixture of alcohol and a sodium salt, sodium or a potassium salt of your carboxylic acid. So when formaldehyde is treated, the alcohol will be your methanol, yes, and that of your salt will be potassium formate. Potassium formate. Yes. Similarly, when you use your benzaldehyde, CHO, treating that one with a concentrated KOH. Yes. concentrated KOH on heating. So what you'll be getting? So here first of all you'll be getting as CH2 benzene ring, CH2OH benzyl alcohol plus potassium benzoate, COONA. What is this? Ester alva, COO group idre ester it is. So this is called as what? Benzyl alcohol, and this is your potassium benzoate. NaOH use ಮಾಡಿದ್ರೆ sodium benzoate. That's the thing. Potassium benzoate. Very much important. These two are also important. They can ask you directly. Okay. What happens when you treat formaldehyde with a strong KOH or a concentrated KOH? You should write both the products, methanol and potassium formate, along with their structures. So you can observe that both the reactants ali namatra alpha hydrogen atoms illa. And one of the interesting fact what you have to remember in a Cannizzaro's reaction is whenever such aldehydes which are not having the alpha hydrogen atoms are treated with a strong solution of your alkali, they are undergoing simultaneous oxidation as well as reduction. I repeat, the compound is undergoing simultaneous oxidation and reduction, which itself, this is an example of a disproportionation reaction. It is undergoing simultaneous oxidation and reduction to give alcohol and that of your salt of a sodium salt of your carboxylic acid. And this is an example of disproportionation reaction. So that is one of the important noteworthy point of your Cannizzaro's. So our simultaneous oxidation reduction product namadu alcohol, one salt of your carboxylic acid. Okay, and this type of a reaction is called as what? Cannizzaro reaction, mainly employed for the aldehydes which are not having, mark my words, not having the alpha hydrogen atom. Very much important to know these two. Formaldehyde gives you methanol and potassium format. When it is with KOH, NaOH is sodium format. Remember what type of an alkali you are using is very much important. Other benzaldehyde, when it's treated with a concentrated KOH, you are getting benzyl alcohol and other of your potassium benzoate. NaOH use ಮಾಡಿದ್ರೆ alcohol same ಇರುತ್ತೆ, salt change ಆಗುತ್ತೆ. ಇಲ್ಲಿ NaOH use ಮಾಡಿದ್ರೆ sodium benzoate ಬರುತ್ತೆ. Yes or no? So these are the three important reactions we have learned so far with respect to the chemical reactions of your aldehydes and ketones which are involving alpha hydrogen atoms and not involving alpha hydrogen atoms when they are treated with a dilute alkali and that of your strong solution of alkali. Very much important concept both in the point of your board exam and in the point of your competitive exams. Okay, I hope so it's clear. If there is any doubt, you can just pause the video and you can look once again, or you can just ask the question in the comment section.